Okay, we're going to hope this works this time. All right, we are going to start back with reviewing how to solve exponentials using the common base. So when we have things like 5 to the x equals 5 or equals 25, we can convert this to a common base. Once we got that, we can ignore our base and solve for our variable. Okay, the next one, we have to convert both. Then use those rules of exponents to multiply. We end up with 3x equals 2. So x equals 2/3. All right, same thing with the next one. We have to convert both. 3 to the 3, 3 to the 4th. So 3x equals 4, and x equals 4/3. All right, next one's a bit more complicated. We got fractional bases, fractional exponents, but I should notice I've got a 7 and a 49, 3 and 9. Those obviously go together. So this would be 7 squared over 3 squared. If my base is the same on the top and the bottom, I can pull that out. Okay, and then I still have my x. And then notice I've got 7 over 3 and 3 over 7, so I have to flip one of these. It doesn't matter which one you flip when you're flipping your base and just making your exponent negative. So this would be a negative 2x equals 3 over 2. If you flip the other side, you would flip your base, but your exponent would become negative, so this would be a 2x equals negative 3/2. Don't flip your exponent. Either way, you're going to end up with the same answer. I'm going to divide by negative 2, which is the same as multiplying by negative 1/2. So I have a negative 3 over 4. This one, if I divide by 2, it's the same as multiplying by 1/2. I still get negative 3 over 4. Okay, so make sure you're flipping your base and not your exponent. All right, what we're really going to talk about today is things like this. What do I do when I can't convert to a common base? Hey, I could guess and check, right? This is going to be, how do we get 2 to the whatever is about 14.1, right? We're going to get close maybe that way, but this is going to be super complicated. All right, before you watch this, you should have done the super fun puzzle. All right, and what we're looking for here is what the pattern is. Okay, so if you look at the examples, well, 2 to the 3 is 8, 3 to the 4 is 81, so it must be this to whatever's over here is equal to whatever's in my parentheses. So in this case, this would be a 4. This would be a 2. Right? This one we're looking at 5 to the 3 is 125. 2 to the negative 1 is a half. 10 to the what gives me 1 over 1,000. Well, 10 to the 3 is 1,000. Negative is going to turn that into a fraction. What squared gives me 81, so that's going to be a 9. Again, what to the 4th is 81. This is a 3. And this one is 16 to the what gives me 64. This one's a little bit more complicated because this doesn't work well like these others do. So what I'm going to do is I'm going to go back to my rules of exponents. Now I'm going to do this. So erase that for a second. We're going to take 16 to the x equals 64, right? So this would be 4 squared, my common base. This is 4 cubed. So 2x equals 3, and x equals 3/2. Okay, so the answer here is 3/2. All right, this pattern is called a logarithm. All right, so in your calculator, you'll see it written as log. And what we can do is use this to undo exponentials, just like add and subtract undo each other, multiply and divide. Logarithms and exponentials undo each other. So the way that we can do this to convert, if we have some exponential we don't know, like our 14.1 to the x equals 2, we can convert this into a logarithm form. And what we're going to do is we are going to take the base of our exponential, that's going to become the base of our log. Our answer is going to be there. What we're trying to solve is going to go on the other side of the equal sign. Now, your iPad calculators will actually allow you to type this in. They'll allow you to change the base of your log. The calculators that I have that you're going to use for your tests do not. So we need to figure out a way that we can calculate this without being able to change this base. Now, the identity base just like we have identity functions for multiplication, which is 1 that doesn't change anything. Adding 0 doesn't change anything. A log with a base of 10 is kind of the identity for logs. What this does is the log of 10 with a base of 10 is equal to 1. So that really doesn't do anything. And so in your calculator, it automatically calculates things as a log with a base of 10. So we need to convert these into a common base so that we can figure these out. And that's what this does. So instead of being able to change our base, now we're converting everything to a log with a base of 10. And the way that we do that is we're going to take the log of our number divided by the log of our base. So when we had trying to solve this, this would be the log of 2 divided by the log of 14.1. All right, and that would give you what the answer that we were looking for in our original problem. All right, so this is approximately 2.62. Okay, so if you typed in 14.1 to the 2.262, this would give you approximately the number 2. It's not going to be exact because we had to round. Okay, so we're going to calculate these with a calculator. I know you can do these because there's common bases on these, but we're going to type it into the calculator, like this, and see what you get. So when you type these into the calculator, it will automatically put parentheses in, or it'll just disappear. You have to make sure you close the parentheses before you divide. So you can do this all in one calculation, but you have to be careful to close those parentheses before you divide. Otherwise, it will take the log of 1 over 64 divided by the log of 2 as one calculation, okay? So make sure you close your parentheses. So we know that this should be -6 because 2 to the 6 is 64. We ought to flip it over, so this should be -6 when you type that into your calculator. All right, same thing with this one. We know the answer to this should be 2. And if you type in log of 16 divided by the log of 4, you better get the answer 2 back. All right, so those will just kind of show you that they do work. All right, so now we're actually going to calculate these in a calculator. It's always the log of your number divided by the log of your base. All right, so go ahead and calculate that one. And you should get 3.287 rounded. Next one. You should get 0.146 is our rounded answer. All right, so that's how you're going to calculate these. In Delta Math, there are some problems like these where you should be able to just calculate it without a calculator using those rules of exponents. And then there is a PDF that has a few problems like this where you can't use those rules of exponents in conversions. So just to practice, make sure you're putting them into your calculator right. There's not a lot of problems on there. And that is it for these.